Welcome to Unit 2, Geometry, Intro to Proofs, and Logic. Today we'll be talking about inductive reasoning and counterexamples. Our objective for today is I can verify that a conjecture is false using a counterexample. First, let's explain what inductive reasoning is. It's reasoning that occurs from observing a pattern. So in our example given below, 2, 4, 6, 8, and 10, the pattern I notice is plus 2 each time. And that statement that I just wrote there, plus 2 each time, is what we call a conjecture. A conjecture is a concluding statement reached using inductive reasoning. So, in short, conjectures are really just educated guesses. So taking all of the knowledge and all of the information that I have learned since I was born and looking at the sequence of numbers or sequence of whatever given, I can come to the conclusion that between each sequence, we're adding by 2. So the conjecture I make is the numbers are increasing by 2. But something really important for us to note is that just because I had one experience growing up and seeing all of these things and understanding the world in my own way, someone else grew up and understood the world in a completely different way. And so the conjecture that they notice may be very different or just a little bit different from what I see. Now, of course, in our example 2, 4, 6, 8, 10, there's not too much up to interpretation here, but someone could totally make a different conjecture in the long run. Let's go ahead and apply some of this knowledge now to example 1. Example 1 says, write a conjecture that describes the pattern in each sequence. Then use your conjecture to find the next items in the sequence. Now, typically, I'd ask you to write the conjectures as sentences or in some way that would demonstrate what you're doing. For each of these, your conjecture can be just as simple as saying, okay, from 38 to 31, I'm noticing that it's subtracting by 7. And same for 31 to 24 and 24 to 17. And it should be a consistent pattern. Now, if that's the pattern that I want to go with, then I need to write the next items in the sequence. So continuing on from 17 minus 7 should give me 10. Minus 7 should give me 3. Then negative 4, negative 11, negative 18. Part B. I notice that I'm given some clock numbers here. 7:30, 7:55, 8:20. From 7:30 to 7:55, I notice they're going up by 25 minutes. And 7:55 to 8:20, also going up by 25 minutes. And so, based on my conjecture that they're all increasing by 25 minutes, my next value would be 8:45, then 9:10, 9:35, 10 o'clock, 10:25. Let's keep moving along here. Now I see a triangle, a square, and a pentagon. One of the things I know about each of these is their number of sides. That's a pretty obvious thing to each of them. The triangle has 3 sides, the square has 4, 5, and so my conjecture is increasing by 1 side. Which means my next one should be a hexagon with 6 sides. Then a heptagon with 7 sides. And lastly, an octagon with 8 sides. Part D, it gets a little more complicated. We see we have 1, 1, 2, 3, 5, and 8. How in the world do those tie together? Because it doesn't look like I can just add a consistent number each time, or subtract one, or multiply or divide a consistent number. Well, what kind of pattern is going on here? I want you to take a moment and pause the video and see if you can figure out what pattern is going on. Go ahead and pause your videos now. So, what pattern might be going on here? Well, this is a little bit more of an advanced pattern, but if we just take a moment and really think about what's going on here, I see I have 1 and 1. Then I have 2. So how did we get from 1 to 1? And then how did we get from 1 to 1 to 2? Well, one thing, and this is just a shot in the dark, it's a spitball, is that if I add 1 and 1 together, that's going to give me 2. Okay, that's pretty reasonable. Does that stay consistent, though? Is that a pattern that stays? To get from 1 to 2, or 1, 2, and then to 3, 1 plus 2 gives us 3. Okay, I think we're finding a pretty promising pattern. 2 plus 3 gives me 5. 3 plus 5 gives me 8. So my pattern here, and this one you're probably going to have to write out because it's hard to grasp just by what I wrote. It already looks confusing. Say we have number let's do this. Say we label it like this: N1, N2, N3, and so on. So N8 would be N6, right? So we do N1 plus N2, and that's going to give me N3. I do N2 plus N3. That's going to give me N4. And so the two previous numbers, what we see with this is that our two previous numbers add together to give me the next number in the sequence. So add two previous numbers to get the next number. And that's my conjecture here, which means if I do 5 plus 8, then my next number should be 13. 8 plus 13 is 21, then 34, 55, 89. So adding our two previous numbers should get us the next number in the sequence. Part E, 3, 1, 4, 1, 5. Now, some might already notice one pattern here, and there's actually two patterns that one was pointed out to me, and one was one that I had intended when I created this. The pattern that I created was just pi, the digits of pi. 3.141592653, and so on. And so my intended pattern would be 9, 2, 6, 5, and 3. However, another teacher had pointed out something interesting to me, which was there is a pattern with every other number. If we look at the first number to the third number, they increase by 1. From the third to the fifth number, they increase by 1. And this was never a pattern that I had intended before. This was purely something that someone pointed out to me. And so if we continue to follow this pattern, then not this blank, but the blank after would be 6 and then 7. And if we look at the numbers in between, it would go 1, 1, and 1. So our pattern would be 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, and probably would go 8, 1, 9, 1, 10, 1, and so on. And this is a huge reason why we have to understand conjectures are not always completely true all the time, should be taken as fact. Because a conjecture is an educated guess. With the experiences that you have had in your life, this is what I believe the result should be. For the other teacher, all the experiences in her life told her that this was the result. And so we ended up with two completely different conjectures, and neither one is definitely wrong because we proved our argument in our own way. So let's go ahead and move on now. Flip to that next page, page 6, and we're talking about counterexample. A counterexample, this is a very important topic. It is an example that proves a conjecture false. So if we go back to the part E, my conjecture was this is all the digits of pi. And then the other teacher proved my example or proved my conjecture false because she found another pattern that was also relevant, that was also valid. So my conjecture, which was that always the digits of pi, wasn't true. And so to provide a counterexample, there are 3 methods. The first is just in writing. Writing a statement. The second example would be using calculations. And the third example would be drawing a picture. So here's an example of a counterexample. If my conjecture is a shape with 4 sides is a square, then the counterexample is rectangles are not squares. They still have 4 sides, they're just not squares. So let's see if we can put that into practice with example number 2. Determine whether conjecture is true or false. If false, provide a counterexample. The product of 2 numbers is always larger than either number. True or false. This is a false statement. Now, I have to prove my true or false. I have to prove that this is false. So I'm going to give a counterexample of this statement. First of all, I've got to have 2 numbers, and it's the product. Okay. So if I did 3 times 4, that's going to give me a positive 12, which we know 12 is greater than 3 and 12 is greater than 4. But what if I made that 4 a negative? Still a number, right? Well, 3 times 4 now becomes a negative 12. And is negative 12 greater than 3? No. So this is a false statement. Part B. The sum of any two consecutive integers is always odd. When we say consecutive, it's one after the other. So the sum of any two consecutive integers is always odd. This is a false statement. Let's prove it. I'm going to use a calculation here. If I choose, let's do 3 and 4, okay? Oh, excuse me. Mr. Devera made a mistake. This should be the sum of any two consecutive integers is always odd. And let's just throw out some examples of this. 3 and 4 would be 3 plus 4 is equal to 7. If we do 4 plus 5, that gives us 9. And these are both odd. And no matter what I try, I am actually always going to get an odd number. So this is true. True. Part C. The sum of two integers is always greater than the difference of two integers. So two integers, let's say we do 4 and 6. So 4 plus 6 is going to give me 10. And then 4 minus 6 will give me 10. Excuse me. Will give me a negative 2. And sure, 10 is greater than negative 2. So can I manipulate this so that I get a different experience? I can prove this, so I can prove this wrong. Sure, if I make the 6 negative, 4 plus a negative 6 is going to give me a negative 2. 4 minus a negative 6 is going to give me a positive 10. Well, the sum in this case, where the top one, this was greater than, the bottom one, this is now less than. So we've proven that this is false. Part D, vertical angles are never complementary angles. That's an easy one to prove false. Let's draw some vertical angles here. And let's make those vertical angles 45 degrees each. Complementary angles means it adds to 90. And 45 plus 45 does give us 90. So this is a false statement. Last one, E. If A times B is equal to 0, then either A equals 0 or B is equal to 0. This is actually a true statement. And that's actually one of the founding, it's an identity for multiplication. So A times B is equal to 0, then either A equals 0 or B is equal to 0. I cannot have any possibility where A and B are some number that's not 0, where that's a true statement. So that is section 1 over inductive reasoning and counterexamples. We'll see you next time.